According to the National Electrical Code, GFCI protection is generally not required for sump pumps. NFPA 70 National Electrical Code 2020 681.1 General states that the provisions of this article apply to the installation, operation, and maintenance of sump pumps and sump pump systems. 681.2 GFCI protection specifically states that GFCI protection shall not be required for sump pumps. The rationale behind this is that sump pumps are considered fixed equipment, meaning they are permanently installed and not easily removed. They are not treated as portable plug-in appliances that typically mandate GFCI protection. Also, GFCI protection can be problematic in wet or submerged environments, which is the typical operating condition for sump pumps. However, there are exceptions to this rule. Firstly, if the sump pump is installed in a wet or damp location, GFCI protection might be necessary to mitigate electric shock hazard. Secondly, if the sump pump is connected to a circuit that also feeds other equipment requiring GFCI protection, the sump pump circuit may also need to be GFCI protected. Now, regarding circuit breaker protection, the 20 amp circuit breakers in the duplex control panel offer sufficient overcurrent protection for the 1.5 horsepower sump pumps. Since the sump pumps are permanently installed and not in a wet location, the National Electrical Code does not require GFCI protection in this particular scenario. In conclusion, based on the provided information and the NEC, GFCI protection is not mandatory for the sump pumps in this installation. However, it is always best practice to consult with a qualified electrician to ensure full compliance with all local codes and regulations. It is also important to understand the NEC definitions of locations. A dry location means a location not normally subject to dampness or wetness. A location classified as dry may be temporarily subject to dampness or wetness, as in the case of a building under construction. A damp location means a location subject to moderate degrees of moisture. Examples include some basements, some barns, and some cold storage warehouses. A wet location means an installation in underground locations or in concrete slabs or other masonry in direct contact with the earth, and locations subject to saturation with water or other liquids such as vehicle washing areas, and locations exposed to weather and unprotected. GFCI protection, or ground fault circuit interrupter protection, is a safety measure designed to prevent electrical shock. It works by monitoring the current flowing into and out of a circuit. If there's a difference of even a few milliamperes, it indicates that current is leaking somewhere, potentially through a person. The GFCI trips the circuit almost instantly, cutting off the power and preventing a dangerous shock. A standard circuit breaker protects against overloads and short circuits, which can cause fires. It does this by interrupting the circuit when the current exceeds the safe level for the wiring. However, a circuit breaker doesn't protect against the small current leaks that can cause electric shock. That's where a GFCI comes in. A GFCI outlet or breaker is designed to detect these small leaks and trip the circuit quickly, preventing injury. NEC 210.8 provides the requirements for GFCI protection. Some common locations where GFCI protection is required include bathrooms, kitchens, garages, outdoors, unfinished basements, and areas near water sources. These are areas where the risk of electric shock is higher due to the presence of water or other conductive materials. NEC Article 430 covers motors and motor circuits. This article provides guidelines for the proper wiring, overcurrent protection, and control of motors. It's important to follow these guidelines to ensure the safe and reliable operation of motor-driven equipment. Proper grounding is essential for electrical safety. Grounding provides a low-resistance path for fault current to flow back to the source, allowing the overcurrent protection device, such as a circuit breaker or fuse, to trip and clear the fault. This helps to prevent electric shock and equipment damage. The equipment grounding conductor, or EG, is the path that carries fault current back to the source. It's typically a green or bare copper wire and should be properly connected to all metal enclosures and equipment. Bonding is the process of connecting all metal parts of an electrical system together to create a common ground. This helps to ensure that all metal parts are at the same potential, reducing the risk of electric shock. The size of the conductors used in an electrical circuit is determined by the ampacity of the conductors and the load they will carry. Ampacity is the maximum current a conductor can carry continuously under specific conditions without exceeding its temperature rating. NEC Table 310.16 provides ampacity ratings for various types of conductors based on their size and insulation type. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. They do this by interrupting the circuit when the current exceeds a safe level for the wiring. The size of the overcurrent protection device should be matched to the ampacity of the conductors it protects. A short circuit is a low-resistance connection between 2 points in an electrical circuit that are normally at different voltages. This can cause a large current to flow, which can damage equipment and cause fires. An overload is a condition where the current in an electrical circuit exceeds the ampacity of the conductors. This can cause the conductors to overheat and potentially cause a fire. Voltage drop is the decrease in voltage along a conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction and reduce the efficiency of the electrical system. It is important to minimize voltage drop by using conductors of adequate size and keeping circuit lengths as short as possible. Electrical panels, also known as load centers or breaker boxes, are the distribution points for electrical circuits in a building. They contain circuit breakers or fuses that protect the individual circuits from overloads and short circuits. Electrical panels should be properly labeled to indicate the circuits they serve. All electrical work should be performed by qualified electricians who are familiar with the NEC and local codes. This helps to ensure that the work is done safely and correctly. Electrical inspections are conducted by qualified inspectors to verify that electrical installations comply with the NEC and local codes. The electrical permits are required for many types of electrical work. These permits ensure that the work is inspected and complies with applicable codes and regulations. When working on electrical systems, it is important to always energize the circuit before starting work. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Use a voltage tester to verify that the circuit is energized before touching any wires or components. Personal protective equipment, or PPE, is essential for electrical safety. This includes items such as safety glasses, rubber gloves, and insulated tools. Always use PPE when working on or near electrical equipment. Lockout-tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. These procedures involve locking out the power source and tagging it to indicate that the equipment is being worked on. Arc flash is a dangerous electrical hazard that can occur when there is a short circuit or other fault in an electrical system. Arc flash can cause severe burns, blindness, and even death. Arc flash hazard analysis is a study that identifies potential arc flash hazards and determines the appropriate PPE required to protect workers from these hazards. The National Electrical Manufacturers Association, or NEMA, is an organization that develops standards for electrical equipment. NEMA standards help to ensure that electrical equipment is safe and reliable. The Underwriters Laboratories, or UL, is an independent testing organization that tests and certifies electrical products. UL listing indicates that a product has been tested and meets applicable safety standards. In general, fixed appliances, like permanently installed sump pumps, are less likely to require GFCI protection compared to portable appliances. This is because the risk of electric shock is lower with fixed appliances since they are not moved around and plugged in frequently. Local electrical codes may have additional requirements beyond the NEC. It is important to check with the local authorities to ensure compliance with all applicable codes and regulations. The authority having jurisdiction, or OJ, is the organization or individual responsible for enforcing electrical codes and regulations. The AHJ may be a local building department, a state electrical board, or another regulatory agency. When in doubt, it is always best to consult with a qualified electrician or electrical inspector. They can provide guidance on the NEC and local codes and help to ensure that your electrical installation is safe and compliant. Keeping electrical equipment dry is essential for electrical safety. Water can conduct electricity and increase the risk of electric shock. It is important to protect electrical equipment from moisture and to avoid using electrical appliances in wet locations. Regularly inspect electrical cords and plugs for damage. Replace any cords or plugs that are cracked, frayed, or otherwise damaged. Do not overload electrical circuits. Overloading a circuit can cause the wires to overheat and potentially cause a fire. Use extension cords sparingly and only when necessary. Make sure that extension cords are properly sized for the load they will carry. Never run extension cords under rugs or carpets. This can cause the cords to overheat and create a fire hazard. Use surge protectors to protect sensitive electronic equipment from power surges. Power surges can damage electronic equipment and cause data loss. Install smoke detectors in your home to provide early warning of a fire. Test smoke detectors regularly to ensure that they are working properly. Have a fire extinguisher readily available in case of a fire. Make sure that everyone in the household knows how to use the fire extinguisher. Educate yourself and your family about electrical safety. This can help to prevent electrical accidents and injuries. If you have any questions or concerns about electrical safety, consult with a qualified electrician. Remember, electrical safety is everyone's responsibility. By following these guidelines, you can help to prevent electrical accidents and injuries. It is crucial to understand the specific requirements of the NEC and local codes regarding GFCI protection for sump pumps and other electrical equipment. Consulting with a qualified electrician or electrical inspector is always recommended to ensure compliance and safety. Always prioritize safety when working with electricity and take the necessary precautions to prevent electric shock and other hazards. By understanding the principles of electrical safety and following the guidelines of the NEC and local codes, you can create a safe and reliable electrical system for your home or business. Remember that electrical codes and regulations are constantly evolving, so it is important to stay up to date on the latest requirements. Continuous learning and professional development are essential for electricians and other electrical professionals to ensure that they are providing the best possible service to their clients. In addition to GFCI protection, there are other important safety measures that should be considered when installing and maintaining electrical equipment. These include proper grounding, bonding, overcurrent protection, and surge protection. Each of these measures plays a critical role in protecting people and property from electrical hazards. Grounding provides a low-resistance path for fault current to flow back to the source, allowing the overcurrent protection device to trip and clear the fault. Bonding ensures that all metal parts of an electrical system are at the same potential, reducing the risk of electric shock. Overcurrent protection devices, such as circuit breakers and fuses, protect electrical circuits from overloads and short circuits. Surge protectors protect sensitive electronic equipment from power surges. It is also important to regularly inspect electrical equipment for signs of damage or wear. Look for cracked or frayed cords, loose connections, and other potential hazards. Replace any damaged equipment immediately. Never attempt to repair electrical equipment unless you are a qualified electrician. Electrical repairs should always be performed by a qualified professional to ensure that the work is done safely and correctly. If you are planning to install new electrical equipment or make changes to your existing electrical system, it is important to obtain the necessary permits and inspections. This will help to ensure that the work is done in compliance with applicable codes and regulations. The permit and inspection process also provides an opportunity for a qualified electrical inspector to review the plans and identify any potential safety hazards. In addition to the NEC, there are other standards and guidelines that may be relevant to electrical installations. These include standards from organizations such as NEC and the Institute of Electrical and Electronics Engineers, or IEE. These standards provide detailed information on the design, construction, and testing of electrical equipment. It is also important to be aware of the potential environmental impacts of electrical equipment. Electrical equipment can contain hazardous materials, such as lead and mercury, which can pose a risk to the environment if not properly disposed of. It is important to recycle electrical equipment whenever possible and to dispose of hazardous materials in accordance with applicable regulations. Finally, it is important to remember that electrical safety is an ongoing process. It is not enough to simply install electrical equipment and then forget about it. Regular maintenance and inspections are essential to ensure that the electrical system remains safe and reliable over time. By following these guidelines and staying informed about the latest electrical safety practices, you can help to create a safe and healthy environment for yourself, your family, and your community. When dealing with electrical systems, especially concerning safety measures like GFCI protection for sump pumps, the specific context of the installation is crucial. Factors such as the location, damp, wet, or dry, the type of equipment connected to the circuit, and local code requirements all play a significant role in determining the necessary safety measures. For instance, while the NEC generally does not require GFCI protection for permanently installed sump pumps, this might change if the sump pump is located in a damp or wet environment or if local codes have stricter requirements. Always prioritize consulting with a qualified electrician to ensure compliance with all applicable codes and regulations and to address any specific safety concerns related to the installation. Furthermore, it's essential to stay informed about any updates or revisions to the NEC or local codes, as these regulations can change over time. Regularly reviewing electrical safety practices and seeking professional guidance, when needed, are key to maintaining a safe and reliable electrical system. Beyond the specific issue of GFCI protection for sump pumps, a broader understanding of electrical safety principles is invaluable. This includes knowledge of grounding, bonding, overcurrent protection, and other safety measures that help to prevent electrical hazards. A comprehensive approach to electrical safety not only protects individuals and property, but also contributes to the overall reliability and efficiency of electrical systems. In any electrical installation, it's crucial to use appropriate materials and equipment that meet industry standards and are suitable for the intended application. This includes selecting the correct wire size, conduit type, and electrical boxes. Using substandard or inappropriate materials can compromise safety and lead to premature equipment failure. Regularly inspecting electrical systems for any signs of damage or wear is also essential. Look for frayed wires, cracked insulation, loose connections, and other potential hazards. Addressing these issues promptly can prevent more serious problems from developing and ensure the continued safe operation of the electrical system. Proper labeling of electrical panels and circuits is another important aspect of electrical safety. Clearly labeling each circuit breaker or fuse with the corresponding load it serves can help prevent confusion and make it easier to troubleshoot any electrical issues. Additionally, it's crucial to follow lockout-tagout procedures when performing maintenance or repairs on electrical equipment. This involves disconnecting the power source and placing a lock and tag on the disconnect switch to prevent accidental re-energization while work is in progress. Electrical safety training is essential for anyone who works with or around electrical equipment. This training should cover topics such as basic electrical principles, hazard recognition, safe work practices, and the proper use of personal protective equipment. By investing in electrical safety training, employers can help to create a safer work environment and reduce the risk of electrical accidents. The 20-amp breakers likely provide the necessary protection for the pumps themselves and the wiring to them.